So initially when I did out this problem, I made the source be DC voltage, but really the source is AC voltage. So we can solve for current in terms of time, write the expression out, but first we need to know the equivalent impedance, and we do that by adding the impedance of the capacitor with the impedance of the resistor, which is equal to negative J all over omega C plus R. And omega is equal to 2 pi times the frequency, which is 60. And then we know that the resistance is just 120. And so then we separate that out in terms of vectors, and we use the equivalent to Pythag theorem, and we square the terms and then take the square root of the total. So we get the equivalent impedance to 170.11 ohms. Then we can rewrite current in terms of time, and that is this equation here, and we know that V naught is equal to 10 volts, and we know that the equivalent impedance is 170.11 ohms. This fraction is equal to 0.0588 amps. And then we rewrite this term in terms of cosine and sine, but we can make, because the sine term is imaginary, as the J is out in front, we just cancel this out because we're only taking the real part. So we can rewrite it in terms of 0.0588 cosine omega t minus theta. And theta is just the inverse tangent of the impedance of the resistor over the impedance of the capacitor. So we get theta equal to negative 0.0783 radians. And we can rewrite that. The current in terms of time is equal to 0.0588 amps cosine omega t plus 0.783.